Hello everyone, welcome back to Lemon Code 21 video. In this video, we are going to create a simple CRUD, create, read, update, delete REST API using FastAPI and Prisma ORM. Before we begin, you might be wondering what Prisma is. Prisma is one of the object relational mapping tools used to facilitate interaction between applications and databases. It's typically used by JavaScript or TypeScript developers. In this tutorial, we will be using it with FastAPI. First, my friends, let's create a project using either Visual Studio Code or PyCharm. In this case, I'll create it using PyCharm. We open the settings and within our project, we add a virtual environment for Python. Then, we add the dependencies which are FastAPI, Unicorn, and Prisma. Once that's done, we create the application start in the main file. Next, we create an initialization function and declare the FastAPI app. We also add startup and shutdown functions. After that, we create a simple home router. Finally, we run the main Python function. We execute it, and there we go. The application is up and running. Now, let's integrate Prisma with FastAPI. Create a file named .env and define a variable called database_URL in it. In this variable, write the URL for your database. Next, create a folder named Prisma, and inside it, you'll find a Prisma schema file. Here, you'll specify the tables to be generated, and the database provider. Create a function to generate a Prisma client as a provider for Prisma in Python. Define a data source for the database, which, in this case, is PostgreSQL. Next, let's create a post model with attributes such as ID, title, content, and description. Add configuration connection. Next, we'll create a database connection class. We'll create a Prisma connection class with an init method. Inside this class, we'll create the Prisma client class and add two functions, connect and disconnect. Moving on, we'll add the Prisma connection function to the main file during startup and disconnect it during shutdown. Before running the application, we'll migrate the tables from Prisma to the database by running the command Prisma migrate. And generate the tables by running Prisma generate. Afterward, we'll check the database to confirm that the post table has been successfully created. We'll create a model. In this case, the model is not directly associated with a database table, but functions as a class mapper when required within the service and controller layers. Let's add a repository. First, we'll create a repository layer. To begin, we'll implement a method to get all the data. We can start by retrieving a Prisma connection variable from the configuration and use the findMany function to fetch all the data. Next, we'll create a create function that takes a parameter of the creator_post class. Within this function, we'll use the create function provided by Prisma and map its attributes accordingly. We'll also create a getById function where we can utilize the findFirst function from Prisma. We'll add a where clause to specify which data we want to retrieve based on the provided criteria. Moving on to the delete function, we can use the delete function provided by Prisma. Finally, for the update operation, Prisma already provides an update function. We'll use this function and specify the attributes that need to be modified. Add service layer. Next, let's create a service layer that contains standard CRUD operations, which we can call from the repository class we've already created. add controller layer. Before we create the controller, let's create a schema file. In this file, we'll define a response class with attributes detail and result. Next, we'll create the controller for the post entity. First, we'll set up the router with a prefix and tag it as post. We'll create a GET endpoint by calling the getAll function from the post service. Similarly, we'll create GET endpoints by ID and implement the other CRUD methods by calling the corresponding functions from the post service. With everything set up, it's time to perform a PI testing. Before testing, let's add a POST router in the main file. Afterward, we can open the browser and access the Swagger documentation. Here, we can conduct testing. First, we'll create a post by providing the necessary data. Once successful, we can retrieve the data using the GET All API endpoint. We can also fetch a single data entry by specifying its ID, and this should work as expected. Next, we'll update the data and if successful, we'll proceed to delete an entry with ID 1. If any errors occur, they may be due to a missing where-id condition in the query. We can add this condition. Retry the delete operation, and it should work correctly.